And here we go. It's recording exercise 9E to A to E revision. Let's see what you remember. I'm going to call out a couple of names. Sample space. This is the notation that's called epsilon. You can do like a backwards kind of 3. Right? So epsilon is the set of all possible, yeah, that's true, numbers. Usually the proper term is called outcomes. So results. So here's an example. What's the sample space of rolling a dice? Sample space is equal to?
1, 2, 3, 4, 5, 6.
Good. So when you list it out, you use curly brackets. 1, 2, 3, 4, 5, 6, close curly brackets. Sample space means all the possible outcomes that you can get when you roll a dice. I can get 1, 2, 3, 4, 5, 6. Yeah? Flipping a coin, I can get heads and tails. Event. What is an event again? Event is a subset of the sample space. So sample space is all the possible outcomes. An event is a particular set or group of numbers or outcomes that you're interested in. Hence why it's a subset of a sample space. So what am I really trying to say? I could say something like, if I rolled a dice, that's my sample space. Then a subset or an event could be, what's the probability of getting a 3? So 3 is one of the outcomes out of your sample space. Okay, in this case, I've got 6 different numbers. That's why we say the probability is 1 out of the total of 6 outcomes. But I could have easily switched the question and made it a bit harder, and I could have said, what's the chances of getting a 3 or an even number? Okay, and that changes the nature of the question a bit. Again, I got 6 numbers there. So my sample space is still 6, but out of 6, how many of them are either I'm going to get an even or I'm going to get a 3? So even is 2, 4, 6. So I got 3 there, plus an extra 3. So that's 4 numbers out of 6. I have 4 to 6 chance of getting that. Okay, but this is called the event. So what I'm highlighting here, this is called the event. So what is it that you're focused on? And usually the event is denoted with a capital letter. You don't use a lowercase letter. You always use a capital letter to denote an event. Back then in year 7, it was called a set. Okay, but the language we use now is called event. So they said set A or event A means the same thing. Yeah. So note there, I'm just going to write here set/event, capital letter. Yep. And you must simplify it to 2/3 as your answer in the exam. Okay. All right, complementary event. Hands up. What's a complementary event again, if you remember? Yes, Ian.
Like odd numbers.
Not so much odd numbers.
Every number is not that.
Very good. Okay, so it's every element or every outcome. That's not the one that you're looking for. So the complement of any event is denoted with a dash. So a dash or a prime. And it is the set of outcomes that is not part of event A. Okay, so whatever the event that you were looking for, the complementary event is the everything that's not that. Probability of A, so we say probability, but we use the notation capital PR. You have to start using this notation. In year 11, you would have started in year 8. Well, at least I'm starting my year 8 with this one. That's what we're doing at the moment, probability. So I'm teaching them to use these notations. Instead of calling it event, I call it sets. So I say probability of set A. Now, a couple of things about probabilities that we already know. Probability cannot be negative. So if you roll a dice, you kind of get negative 30% chance. So hence why it is always above or equal to 0. The sum of all probabilities or all the outcomes have to equal to 1. Because if you get every single item, so 1, 2, 3, 4, 5, 6, when you roll a dice, well then you got 100% of the data. But 100% just means 100 out of 100. That's why if you add them all the probabilities together should add up to 1. Okay. Probability is calculated as total number of outcomes, which is your sample space, and your interested outcome that you're looking for. So whatever event A is. What's the N by notation? So this is clearly sample space. What's the letter N in front of epsilon? Number. The technical name is called the cardinal number, and it just means the number of elements that sample space has. Okay, but if you think of N as number, it's how many items does the sample space have, and how many items does the event A have. That's what N stands for. Okay, so if you want me to write it down, the proper name for it is the cardinal number, which really just means number of items. Can we turn that off, please? Yeah. Number of items. Okay. That's just the language component of probability. Let's do some problems now. So what are some skills you must learn? I'm just going to summarize on a corner over here. So any of these terms that seem scary to you, that's where you go back and revise. You don't need to do the exercises. That booklet that I've printed out for you is to save you time from going through the exercises. But if you want to pinpoint which skills to just practice, then you can go to your textbook as well. Yeah. But these are some things that you must know. I'm going to write on the side. These are things you must know. Tree diagram. Do you know how to draw a tree diagram? So back from year 7 to 10, have you learned how to use a tree diagram? So for example, if I flip a coin twice, do you know how to draw it like heads, tails, heads, tails, heads, tails? Write out the probability. You got half, 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 half. But then the tree diagram has one rule. It's called the multiplication rule. Hands up if you remember what the multiplication rule is. Anthony. Very good. So if I wanted to know what's the probability of getting H on the first go, T on the second go. So I'm asking what's the probability of getting H and T, or intersection T? That is equal to the probability of H. So first getting a H times probability of T. What I just wrote here, the intersection of H and T is equal to probability of H times probability of T. That's called the multiplication rule. Okay, this links into exercise 9F, conditional versus non-conditional. This at the moment is non-conditional. Yeah, so understanding the basics from year 7 to 10 will help you to understand why I teach you 9F. Okay, so that skill there, the technical rule is written as probability of A intersects B is equal to probability of A times probability of B. That's what the multiplication rule is. And that's what allows you to use in tree diagrams. Next one. Venn diagrams. You learnt back in year 9, Venn diagrams have 4 significant regions. You've got, I'll color them, the one in the center that overlaps between group A and group B. You have the group that only has A. You have the group that only has B. And you've got the white region, which is everything outside of A and B. Now, those 4 regions had special symbols that you needed to remember. The first one was easy. The middle there is A intersection B. What was the white region? That's the next easiest one. Ooh. It is the excluding one, but how do you do it? It's got A dash, B dash, intersection. If you really think about it, it's really saying not A, so think about everything outside of that circle there. So I would color everything outside. And not B. So if I'm not coloring everything outside of B, then the only ones that don't include A and doesn't include B, it's the white region. That's what that means. Yeah? Then how do you describe the blue region here? It is A. Good. Then the last one. Very good. This links into two-way tables. So this is what you did in year 9. So you got A, not A, B, not B. And those 4 boxes represent the 4 regions you see there. So A intersection B is the yellow region. B, but not A, represents the red region. A, but not B, represents the blue region. And then not A, not B, represents the white region. So if this thing here is confusing you, you got to go back and revise. Yeah, so this is year 7 to 10 mathematics probability. Year 9, I'm pretty sure I taught that last year, the year 9 group. And we know that all the probabilities should add up to 1. So that would be probability of A, so PR of A. This is PR of not A. This is PR of not B. And PR of B. That's the two-way table. Proper name is Carnot maps. Carnot maps. But usually your textbooks, they call it two-way tables. Yeah? That's probably one of the most testable ones in junior maths. So if I were to make a test right now for my juniors, I would do some variation of that. At year 12 level, these two are used quite often, especially this one. Okay, because there's a lot of things that you can learn from it. Notice there's something special when I colored it as well, because this links into a second rule that you learnt back in year 9 as well. It's called the addition rule. Anyone remember? What was the addition rule again? So I taught you the multiplication rule. Well, not taught, but revised it. Anyone remember what the addition rule was? So hands up? No? I'll start you off. Probability of A union B is equal to? So A union means A grouped with B. You can even look at the diagram and you can probably figure it out. Probability of A plus probability of B. Whoops. Probability of B minus probability of A intersection B. Now, if you look at this diagram, it makes a lot of sense why we gave you that rule. Probability of A just means all that. So that means it's the blue and the yellow region. And then, plusing, notice that A is the blue and yellow, but then B is the pink and yellow. So you doubled up the yellow twice. Because you're adding blue, yellow, so that's blue, yellow, and then yellow, red. So yellow is counted twice. That's why you minus the yellow once. That's where it's coming from. Yeah, so you're saying A is blue and yellow. This is red and yellow. So you counted yellow twice. That's why we minus yellow an extra time. But what's special is most students either use the rule, but they don't realize in the Carnot maps, it also tells you. See, A union B just means color all of A and color all of B, right? That's just blue plus yellow plus red. In your Carnot maps, if you actually just add these 3 regions, that's the same as finding A union B, which is what the year 12s do. Okay, so year 12 questions, we sneak it in, and we don't give them this, but they were meant to be able to figure out that you add these 3 regions, and it will be the same thing. Okay, so maybe color that in just so that you know or remind yourselves. But this is a huge revision of your year 7 and year 10 probability so far. So far, so good. So there are 2 rules: multiplication rule, addition rule, 3 types of diagrams, tree diagram, Venn diagram, two-way tables. How's that sound so far? Pretty good? If I zoom out, that's your year 7 to 10 knowledge. Okay, so there's different types of questions, and 9A to E practices those skills, how fluent you are with utilizing that. Clear? All right, let's do the first question. Give you a bit of a vibe. Let's start over the first one. So here, let's read this question here. It says, exercise 9A, question 14, for a particular biased six-sided die, it is known that the numbers 2, 3, 4, and 5 are equally likely to occur. So 2, 3, 4, and 5 have an equal chance of occurring. Whereas the number 6 occurs twice as often as number 2. And that number 1 occurs half as often as number 2. Ooh. So how do we apply this? Well, this is what we do. Whatever the chances are of getting 2, 3, 4, and 5, I don't care. I just know they're equal. So I can call it X. If I called it X, chance of getting a 2 is X. Well, then chance of getting 3 is the same. Getting a 4 is the same. Getting 5 is the same. So you don't need to know the number. You just say whatever the chances are, right? Because probability of X equals to 2. Oh, this is another notation if you're not used to it as well. This just means probability of X equals to one of these numbers here. So it could be 2. Probability of X equals 1. That's what that represents. Okay? All right, so here probability of X equals 2 is X. Chance of getting a 2 is X. Chance of getting 3 is X. Chance of getting 4 is an X. Chance of getting a 5 is X. But then the next part we said is that to get a 6, you have twice the chance of getting number 2. So what would I fill in 6? 2X. So double the chance. And then in number 1, it says that it is half as often as number 2. So then it must mean, yeah, X on 2 or 0.5 of X. Whichever one, doesn't matter. But now if that's all the possible outcomes, you roll a dice, you get 1, 2, 3, 4, 5, 6. These are the chances, but we know our properties from probability that the sum of all probabilities must add up to 1. Yeah, so if you add all the probabilities, it should be 100%. So that means if I added all the probabilities together, chance of getting 1, chance of getting a 2, that means 0.5x plus x plus x plus x plus x plus 2x should equal to 1. Now we can solve out what the chances are. So here we go. 1 plus 1 plus 1 plus 1 is 4. 4 plus 2 is 6. And 6 plus a half is 6.5 times x. 6.5 is 13 on 2. So to solve for x, you can times both sides by 2 and then divide it by 13. Therefore, x must be 2/13. Or you can change that to a decimal if you want. Have I skipped too many steps or is that doable? Pretty good. So that's part A. Find the probability of each possible outcome, which I have. Now that I know x is 2/13, then I can work out all the other ones. That means the chances of getting a 1 should be half of that. So it's 1 out of 13, 2 out of 13, 2 out of 13, 2 out of 13, 2 out of 13, and you get double the chances here, so it's 4 out of 13. So if you add all the numbers together, it should actually be 13 out of 13. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and 9 plus 4 is 13. So it makes sense. So I've answered part A. Part B, find the probability that the number observed is not a 6. They're saying find the probability of not 6. See my notation? PR, probability, event is 6 but dash because it's a complementary event. How do you find the probability of not getting a 6? There's 2 ways to do it. You can either add probability of 1 plus probability of 2 plus probability of 3 plus 4 plus 5. That's the chance of not getting a 6. Or the quicker way, since the total has to add up to 1, just minus the probability of actually getting a 6. 1 minus probably getting a 6 is 4 out of 13. So how many chances do you have? 13 out of 13, take away 4. 9/13. So it's up to you. You could either add them individually. You could have done that plus that plus that plus that plus that. That's all the chances of not getting a 6. Or I could have taken the total minus this chance. And I would have got the same thing. Okay, so there's 2 ways of doing it. I like doing it this way because that's what the year 12s do. So I just wanted you to get familiar with different ways of getting your answer. But how does that feel so far? That's exercise 9A. Okay, so we're using one property, bit of problem solving, and then solving what you need. So as you go through them, some of them will stump you, but that's the idea. There's only so much content from year 7 to 10 that you need to know. This is the main area. There's the basic knowledge. Terminology, techniques. Yeah? Let's try the next one. I'm going to pause the video and let's see if you can have a go with this one. Those you had to go, to work out the probability, you literally just work out, well, this is the region I want out of the entire region. Just like probability in general, you've got to find the total, and then what's your desired area. So in this case, to find the desired area, you're taking the big circle and you minus the small circle, and you'll get the leftover desired area. So big circle has a radius of 14. So big circle is 14 pi r squared. Okay, so pi times radius squared minus the area of the smaller circle has a radius of 7. Pi times 7 squared. Out of the total area, which is the entire region here, which is 14, which is the big circle. So 14 pi r squared. Hands up if you at least had that general direction in working out. You're trying to do desired over total. Good. So area of a circle. And now let's just plug into a calculator. So do I have a calculator ready? Oh, I do. Cool. Let's see. It was pi times 14 squared minus pi times 7 squared over pi times 14 squared. You got 3/4 chance, or 75%. So far, so good? Yeah, that's 9A, 9B. 9A to E is going to be pretty easy. It's just going to be mainly about those skills there. So if you get closer to E, you're working on these skills. 9A and B, you're working on these skills here. All right? So work on the booklet, but that's all I wanted to cover today. It was just to give you an intro to what probability is. But the first 5 exercises, it's pretty much revision. Here we go. I'm going to stop the video.